go, we're recording. I want to welcome everybody to this special session of the Denver MuleSoft Meetup group. This is actually being coerced, taken over by the TDX24 talk series. We have a double header for you today. I'm going to reprise a session I gave at a community campfire called MuleSoft Automation, Lessons Learned Using MuleSoft Automation. I'm here joined by Aston. Aston's going to be talking about distributed tracing. So again, if you have any questions during the session, go ahead and put them in a chat or in a Q&A. We will take a look at those and make sure we capture it. Again, we'll post the content of this meetup after it has concluded, after I get the recordings. So I'll go ahead and get started. First of all, here's a 2,000-word Salesforce forward-looking statement, which basically means do not make a decision based on anything that doesn't exist today. I will be talking a little bit about roadmap, especially about IDP, so hence the forward-looking statement. So a little bit more about me. I have over 20 years of integration experience, mostly on the Oracle side, so a suite in OIC, which is Oracle Integration Cloud. About 5.5 years ago, I divorced Oracle. Oracle divorced me, doesn't really matter. We separated, and I was fortunate enough to enter the MuleSoft ecosystem. I am currently the director of the MuleSoft practice at Argano. I'm based here just outside of Denver. I am the Denver MuleSoft Meetup group leader, and I've been privileged enough to be a MuleSoft ambassador since 2024. So after this session, you're going to learn about an automation use case that we implemented, what our grand solution design was, what some of the challenges and mitigations what some of the challenges of this solution design, and how we mitigated those challenges, and some key takeaways so you can succeed with your MuleSoft automation solution. So let's go ahead into the use case. So working with what is known as an ERISA compliance company. If you don't know what ERISA is, there it is at the top part. Basically, it's a US federal law that sets standards, minimum standards for keyword involuntarily established, basically benefit plans. Second keyword, private industries. So if you work for a private company in the United States of America, your company has to file ERISA, basically ERISA statements with the Department of Labor and the IRS. What do they have to file? They have to file 5,500 and a Schedule A for every defined voluntary pension, welfare benefit, and contribution pension. So for example, if your company offers medical coverage through either Kaiser or United Healthcare, that's two separate Schedule A's that have to be filed, one for Kaiser, one for United Healthcare. Those of us who are filling out our taxes in the United States, conceptually this is similar to your 1040, which is your base form, and your 1099, which is from your investment companies. As you know, each investment company has an equal and opposite version of that 1099. So that is the automation use case, the compliance background. So what were some of the business challenges that this particular customer mentioned? Well, just like 1040 and 1099, there is a common format for your 5500 and for your Schedule A's, at least on the government side. But from the carriers, if you've seen one Schedule A, you've seen one Schedule A. What does that mean? Well, let's go take a look. So what I have here is an example from Lincoln Financial Group. You could see they have part one, they have some letters here, some important codes there with the extract. The key to the Schedule A forms is really reporting the commissions that are paid to brokers, etc. You can see this kind of sort of looks like a somewhat tab delimited table. Let's compare this with a Kaiser form. Again, we ignore the first two forms. You could see Kaiser is listing NAC. They put NAC code. You can see there's no little letters next to it. And then when you look at the commissions, you can see there's no little table here. It actually is just repeating text top to bottom. So hence the point of when you've seen one Schedule A form, you've seen one Schedule A form. So what this particular business is doing is they are, as I get back into slideshow mode here, what this particular business does is they take these forms and they are using a SaaS called FT William to in effect e-file the client's 5,500 in Schedule A's. Again, in the US, very similar using TurboTax or H&R Block to file your 1040s every year. The existing process is manual. They are keying in that data from the Schedule A's in the 5,500. And Obviously, when you have manual processes, those are error prone. So position MuleSoft Automation to lower the service costs, improve the quality, and allow the company to reallocate the human resource assets from pretty much every client to some more high touch value add that this company can provide. So great. Now we know about the use case. How do we go ahead and implement it? So the implementation is as follows. The clients for this customer basically send in a 5500 template, which is what this customer requires its clients to use, and schedule A's from the carriers. They drop them into something called ShareFile. Conceptually, that's similar to SharePoint. ShareFile generates an Outlook notification when it's received these files. RPA, we're using RPA to basically pull Outlook, find information about these files. We load some key value pairs in object store. And then more importantly, our system API goes and sends a message to Microsoft Teams. That's what this customer is using to say, should we process this form, yes or no? There are some cases where they're going to say, no, do not process this form. We have to handle it manually for whatever reason. But in most cases, they'll say, yes, go ahead and process this form. So then we will take the key information, download the file from SharePoint, send it over to AWS Textract. AWS Textract extracts the fields, and then we take that data, which is JSON, and then send it back to the system API. And the system API is going to go ahead and interact with FT William. There's a fair amount of processing here. While the FT William API is rich, there were certainly some aspects of it that we had to overcome. Namely, in a UI for FT William, there's a requirement to keep all the schedule A's in order on a UI. The API in of itself couldn't handle that. So we almost had to basically grab the order and almost do like soft touches to the documents that we weren't updating to keep them in order on the UI. So absolutely brilliant design. What could have possibly gone wrong with this design? Well, I already mentioned there is no such thing as a common carrier schedule A. One of the other challenges is at the time, the automation subscription only permitted one non-prod and one prod API for API management. And also you only get the root business group. So already we're kind of violating some of the better practices of MuleSoft, especially with the API. That forced us, if we wanted to manage it, and we did, we definitely wanted to secure it. That forced us into a monolithic API. AWS Textract was definitely a challenge. Here's an example of what you get back from AWS Textract. Over here in Notepad++, you could see this was a key, this was just key values extracted out of AWS Textract. You can see these confidence levels. I'll be honest with you, if you're ever going to demonstrate RPA and Textract to a customer, hide the confidence levels because almost every customer is going to like, well, what does it mean it's only 70% confident? Wait, it looks correct to us. Hide that from your customers because it's going to just really throw them for a loop.
I don't think we can see your notepad, Brian.
What's that?
I don't think we can see your app that you're showing.
You can see it? Oh, you're right.
I don't think so.
Oh,
I just thought I'd say.
Let me go ahead and correct that. I thought for sure I shared my whole screen. I guess I didn't. Thank you. How about now? It's right there.
Yes, we can
Rewind,
see that.
delete. Oh, can't do that. Anyway, this is basically a key value pair extraction from AWS Textract. The point I was making is, honestly, if you're demoing this, try to hide the confidence from the customers because they get really, really tripped up. They'll say, well, why is this only 70% confident? What does that really mean? How can we get to 80%, et cetera? So just word to the wise, hide that part of the demo when you demo this to potential end clients. So let's go back to the slideshow. I can see why. The irony, Aston, is I can see exactly what you're seeing, but for some reason I missed that you weren't seeing this. Adding workflow to Microsoft Teams was also a challenge. We kept getting timeouts as it was communicating to Cloud Hub. So let's go. Yeah, one of the questions, what is the good confidence? Well, that actually really depends. I think in general, anything above a 70 was probably good enough. We were actually a little bit more interested in a few key fields, and I'll get to that on the next slide, that had to always be accurate. So how do we mitigate some of our challenges? Again, there's no such thing as a common carrier schedule A. We spent a fair amount of time with the SMEs to basically agree on what fields, what are the field names for a particular field, like you saw NAIC in two different, that was represented differently in two different forms. keep propagating or keep multiplying how many forms we had to deal with. So we agreed on a data mapping, basically data mapping fields that would allow us to get to hopefully an 80-20. In this particular customer's case, is probably more like a 65-35 type of solution. I already talked about the limitation with automation subscriptions, so we had to use a monolithic API. I will get to AWS Textract, and to add workflow to Microsoft Teams, and more importantly, how to communicate with Cloud Hub, we had to create a custom Teams bot. Microsoft Teams does support the concept of adaptive cards, which allows you to more or less have basic approvals, basic escalations, etc. Honestly, if your customer uses Slack, please go with Slack. It is infinitely easier to get this done. This probably takes about half a day, and you get some basic workflow out of Slack. Whereas Teams, we had to basically create our own Teams bot. So let's get into a little bit more about AWS Textract. So there are a few different document processing languages available with AWS Textract. We tried 3 of them. Key values, that's the JSON you saw. That's pretty simple. Give it to AWS Textract, says, okay, go ahead and extract these keys out. Simple to use. However, there were certain fields like NAIC code, EIN, etc. we absolutely positively had to get correct. Otherwise, there was really little point in trying to automate the solution. And sometimes key values didn't quite work that well. It struggled with some of the table formats. We also use ERP documents where you say, well, wait a second, that doesn't look like an invoice. That's what ERP docs are designed to do. However, remember, we're trying to pull out commissions, which are in effect dollar and cents and line items. So we actually found that that worked pretty well. ERP documents processes 1 page at a time. So if a table goes over multiple pages, it struggled with that. And then we also went with strict queries. Queries, you say, give me this field, and it returns that field. This basically got us to about 100% confidence on the critical fields, which we absolutely positively had to have. Otherwise, we weren't going to be able to interact with FT William at all. Again, the struggle we had there is with tables, once again. So our final solution blended ERP docs with queries. We basically run an ERP doc on the invoices, check to see if we got the critical fields. There's like 5 of them we absolutely positively always had to get. If we didn't get them, then we ran a query to get the fields that we missed, and then that allowed us to interact with FT William. However, in some cases, commission tables still required a final manual review. If you remember from the design, one of the last things we did was we would send a report back to Teams saying, hey, this is what we were able to process. And at that point, they could say, yeah, we don't have to worry about checking this one, or they'd say, no, we have to go ahead and just double check this before it got uploaded into FT William. So again, Textract is a bit of a challenge to work with. What's coming up in the product? IDP, which is called Intelligent Document Processing. This is, again, full safe harbor statement at this point. IDP is scheduled to come out sometime this month, probably towards the end of this month. What it's going to do is it's going to simplify the interaction to AWS. Underneath the covers, the solution is still using AWS Textract. It's going to come with a few pre-formatted schemas. I believe it's going to be invoice and purchase orders. As you saw, Schedule A's are neither one of those. It will then allow you to basically create your custom documents, like for example, on Schedule A's. What I've seen is it's basically, in those cases, the custom documents, it's going to be using queries. I believe for POs and invoices, it's going to be able to take advantage of the ERP document part of it. The other advantage to IDP is this is going to, in effect, be a MuleSoft application itself. So conceptually very similar to Composer, which is an app just running in Cloud Hub. This is going to be doing the same thing. So it should allow for performance improvements and a little bit simplified interaction with AWS. It's actually abstracting that part from you. So our customer, they had to have their own AWS Textract or AWS subscription. My understanding is that will not be the case with IDP. So again, IDP is coming out a little bit later on this month. Again, safe harbor statement. Everything I said could be wrong, but I'm reasonably confident it's going to be reasonably accurate. And that's what's going to be the benefits. Ultimately, this will be feeding into the output will be feeding into Einstein. So Einstein will be able to do some of the learning on your documents. So back to what happened with our particular customer. So we talked about the use case, we talked about the implementation, we talked about some of the challenges, and how we mitigate those challenges. So my advice to you, if you want to succeed with MuleSoft Automation, this is a line of business solution. So first, make sure the line of business is in alignment of what is going to be the definition of success. In this particular customer, the SMEs actually were not aligned with their executive staff, so there was some back and forth over that. I strongly recommend implementing some sort of collaborative workflow like Slack or like Teams. Do not go to line of business. Okay, well, if it's wrong, it'll go through, if the document will go to a dead letter queue. They're going to say, dead, what? Grateful Dead? What are you talking about, dead? No. Do not mention a dead letter queue. Go ahead and work, again, use a tool that they're used to for interacting with, like Slack, Teams, Google Chat. I understand IDP is supposed to have a UI that also allows for human interaction. I haven't seen a lot of it yet, so I can't tell you whether that's a good thing or whether I would say, yeah, still use Teams or Slack. And then definitely add time to experiment with your text extraction solution, again, based on the complexity of your documents. If you have one document that has very little changes to it, you're going to be able to automate that quite well. If you have a lot of different formats, that's where you have to mess around with text extraction. AWS Comprehend is more geared towards unstructured data as opposed to like PDF data. So you may have to consider that. The other question I have, was there any signature that was extracted as part of the solution? We were not required to extract any type of manual handwriting. However, Textract will work just fine with that. We're currently doing a proof of concept with another customer, and it works just fine. Where it may struggle is if you go from horizontal to vertical. We've definitely seen Textract struggle with vertical fields on that. So hopefully you've learned something about our experiences with MuleSoft Automation and how you can succeed with it. Again, IDP is an exciting addition to the automation solution. It should be coming a little bit later this month, and we'll ultimately be adding AI to it in Salesforce's quest to add, really enhance generative AI. So with that, I'm going to turn it over to Aston, who's going to talk about distributed tracing. So Aston, the floor is yours.
Thank you very much. Let me just share my tab. Can you see that tab?
Yes, I see a picture. It kind of looks like you.
Yeah, good to hear. Yeah, I was a bit younger, so it's probably why it's just kind of, yeah, I'm lying to myself with that. Anyway, on that note, hi everyone. My name's Aston Whiteling. I'm a senior product marketing manager at MuleSoft, part of Salesforce. And yeah, today I'm going to be talking to you about AI and observability and the future of distributed tracing. So Brian flashed this up already. You know the drill. Don't make purchase decisions based on things in the roadmap. I'm going to be talking about a mix of things that are available and roadmap, more like thought leadership stuff. So just keep that in mind with what I'm about to talk about. Here's the agenda. I'm going to start by talking about what distributed tracing actually is, kind of set the baseline, talk about why it's an important technology, what problems it solves. We'll have a little bit of a look at MuleSoft Anypoint Monitoring as well. And then I'm going to talk about the juicy bits, like how AI is going to impact the world of distributed tracing. So first up, what is distributed tracing? Hands up if you've heard of distributed tracing. I actually can't see the chat, so I can't see if you're putting your hands up. But no matter what your response is, I would or would not be surprised.
I'll raise my hand, but I saw your session.
I know you saw my session, so yeah, that makes sense. I know you're briefed. But yeah, I wouldn't be surprised either way because, if you have heard about it, it's the second biggest project. It's part of OpenTelemetry within the Cloud Native Computing Foundation's project portfolio. That's right after Kubernetes. I'm sure everyone on this call has heard, at least in passing, about Kubernetes. But also, considering it's the second biggest project, you might not have heard about it, and that's kind of interesting. And I'm going to dive into a little bit about why that is later today. But to start, I just say I like this Amazon AWS definition. Distributed tracing is observing data as it flows through a system. I personally, that's the dictionary definition. I like to think about it in using a plumbing analogy. So imagine this is your pipe system, your application network, and you're pumping in data. Data's flowing through your different pipes to get to your different nodes in your network. And then say, your e-commerce system stops working, something blows up, it starts geysering, and then you're going to look at the metrics and logs to try and understand, what's going wrong in that node in your network. Distributed tracing is kind of like adding dye to the water. So you die the flow of data, and you can understand how that data is in fact moving from a holistic sense across your application network. So that's the analogy. In practice, this is a bit more of a technical breakdown. So on the left, you can see, this is what a request looks like. You have a user that makes a request of your system. That initial request is then appended with a trace ID in its header, and as it moves between different applications as part of that request, it is tracked and proliferated. You can see what that looks like on the right hand side. You have your full parent span, which is what we call the distributed trace. That also contains the metadata of the different children's spans as it progresses from application to application. So why is this important? Why is this an important concept in the world of monitoring and observability? Well, it's important because it's kind of changing the paradigm of how we think about monitoring and observability. And it's doing that because it's saying that the request itself, using the request as a unit of measure to understand and interpret health and monitoring data, is actually more valuable than what we traditionally do, which is indexing around events. And that's like things like metrics and logs. And why is that? Well, it's because monitoring a request and understanding how a request is moving is much closer to the actual end user experience. And it's also interconnected. You can kind of see the forest for the trees when you use something like a trace. You're getting that entire holistic network understanding. Whereas with events, things like metrics and logs, it's subjective. Get 5 executives in a room and ask them what the metrics mean. They're all going to say 5 different things, which kind of shift the blame from them. And that's the same with logs as well. Logs are written by developers, and they're the subject of heated debates as well. And on top of that, it's very disjointed. If you're looking at individual logs, you're looking at those specific applications, you're not seeing the forest for the trees in that scenario. So I've said that this is the kind of the new indexing paradigm for monitoring and observability. But of course, the way the world's set up right now, events are still much more highly prioritized as a tool to use when you're evaluating network health. And some of that is, of course, because metrics and logs have been around a lot longer than the concept of distributed tracing. So they're more embedded as a technology. People are more familiar with them. But distributed tracing has been around for long enough now that you'd think there'd be more of an uptick and a more widespread buzz around the industry. So yeah, why hasn't that happened? Again, I blame Dora, and that's not Dora the Explorer. No, they're throwing a mid-journey generated image for you. I blame Dora, the DevOps Research and Assessment Group. Even though it's not their fault, it's more of a response to how the market responded to some of their research. I have another hands up moment, and it's hands up if you read Accelerate. If you haven't read this book, this was a seminal work on the world of DevOps, and from these authors, they were part of the Dora group. And the summation of their findings from this book was essentially to orient around what are now known as the Dora metrics. These are 4 metrics for your DevOps process, which is deployment frequency, lead time to change, time to restore, and change failure rate. And when they came out with this book, the market loved it. This was everyone started trying to do DevOps off the back of this, because it seemed like if you just track these 4 metrics, you're going to have a successful DevOps process. That's kind of the market takeaway. When in reality, if you've ever tried implementing DevOps, it's a little bit more complicated than that. And I think that's because, what I'm getting to is that when you just take a metrics view, something like just tracking 4 metrics towards a particular goal, for example, you're getting a kind of just the broad understanding. You have a goal you're orienting around, and you have your set of metrics, and you're getting that wide view, but perhaps you're not getting the depth that you need to really get to the nit and grit of an issue. And that's where the logs come in. Of course, logs are providing that depth, but they're, again, kind of siloed into specific applications without that wider context. And you can probably guess where I'm going with this. With a trace view, you get the breadth and you get the depth. So with that in mind, what problem does distributed tracing actually solve? This is a great quote I pulled from an article from Matt Semiyuthka on Medium. I have to shout her, this Medium article was a large inspiration for this talk, so I always say that here. She's a great authority and voice on this subject. But I thought this quote was great, really funny. Ask any developer what the most painful moment in their life is, and I'll talk about time spent debugging a Sev1 error with what feels like 100 people breathing down your neck. It's very true. And with that in mind, when you look at the state of how to address these problems now, if you have that 100 people breathing down your neck, say something's wrong in the logs, you're kind of moving between applications, reading the logs, and you're saying, okay, let's try and get a bit more breadth and strategy. Okay, we'll bring in the metrics now and we'll see if we can solve the problem with them as well. And the same is kind of true of the inverse. If you have the metrics and your metrics are blowing up and you say, okay, well, this is the metrics going like this, let's go into the logs and start trying to understand the operational nuance. What's missing here is the context of where do you start and who's actually responsible. And this is what distributed tracing helps answer. So it changes the monitoring process where step one now is look at your trace data. Because it has that broad and deep view, you can see this holistic understanding of your network and where bottlenecks are forming, where the cracks are beginning to form, where things are going wrong. And from that, you can then say, okay, here with this complete view, what are the microservices and who are the teams involved in fixing this problem? And then after that, once you have that established, then you can kind of adopt a more traditional response where you use the logs and the metrics, and then you attempt a solution. So that's the Sev1 breathing down your neck aspect of the problem, but it also provides a tail in the sense that you can take a step back and actually evaluate from a strategic sort of understanding and an operational one. You can say, which way did it lean, like that, the issue we just encountered and just solved. If it's strategic and you want more breadth, then you can go into the metrics, and the inverse, if it's more operational based on specific apps, you can go the depth and look in the logs. So, and that, to the end of improving your your holistic application network health. And this is super important in the modern world of microservice architectures. Great quote from Datadog. I say different teams own different services that are involved in completing these requests. They move across different, business units and teams, applications, and distributed tracing makes it clear where the error is occurring and who's responsible. And this is incredibly important, as I say, in the world of modern microservices and microarchitectures, because they don't look like this anymore. If your application looks like this, perhaps day 3 of your startup, like that's the way the world's moving. You're spinning up a lot of different technologies to really get the most value. And that's so, it doesn't look like something simple like this anymore. In reality, it looks kind of more something like this. I got this graphic from this article by The Register. This is a UK bank called Monzo. This is a visualization of their 1,600 microservices. So with that in mind, is it any wonder that 73% of companies report a mean time to restore that's greater than an hour for their service? And it's increasing as well. So it's becoming more challenging when, your application networks look like this. It's challenging to solve those issues. And distributed tracing is the answer. So I've been waxing lyrical about distributed tracing for the last, I think, 10 minutes or so. And you probably are wondering, if this is, such a holy grail, why is it not seeing more widespread adoption? And it's because distributed tracing has its own challenges. Namely, the first one is to say, to go through them now. To get a network set up for distributed tracing, it's not a simple thing. There's an immediate barrier to entry. And that's because if you want to get the most out of it, you can't just start with 1 or 2 applications. If you really think about distributed tracing, just 1 or 2 applications doesn't really make sense. You want to understand the whole network. And to do that, you need some kind of code agent to go through and essentially prep every one of your apps so that as the requests move through, that they can, handle this and pass this request and then pass it on to the next app in the request, as it moves through your system. So that's kind of an immediate barrier to entry for IT teams. Next up, it's hard to get the right context. Traditionally, you have your trace data, you have this holistic data, you're understanding your network, but then you maybe want to slice and dice it a little bit more and understand across different entities or systems in a more of a contextualized way. And that's traditionally been quite challenging as well. And then finally, it can be this trace data is quite hefty. It can be quite hard to get it out and move it to your third-party monitoring and observability systems as well. So those are 3 issues I just talked about. And wouldn't you know it, MuleSoft from Salesforce has the solution. So this is the portion when I was at TDX and I gave this talk initially. I had my colleague Pushkar come on and give you a demo. I'm not going to give you a demo today, but I'm going to go through 3 new features within Anypoint Monitoring around this concept of distributed tracing that solves those problems. The first one is distributed tracing. So we've implemented that. I talked about this a lot, so hopefully you're very aware of what this is. But yeah, essentially, as requests move between your Mule apps, you can now have these traces appended to those requests, and you can have them propagate across your MuleSoft ecosystem, and you can see that understanding of your holistic application network. The moment this is just for Cloud Hub 2, RTF is coming next year. And then next up is Anypoint Insights. This is the search piece that I was just talking about as well. Essentially, we have the ability to, via a search bar, you can search your trace data and your health monitoring data for more context. So you can understand via different groups or business units, etc., to get that more contextual understanding of your more holistic health and monitoring data. And same as distributed tracing, this is currently CH2 and RTF coming next year. And then finally, telemetry exporter. This is a UI-driven setup configuration wizard that essentially lets you export real-time telemetry data to your third-party ecosystem. So it's based on the OpenTelemetry standard. We can support that standard, whatever the third-party vendor is. If they follow the OTel standards, we can support export some data to it. And this is available for both right now. And that's just a config wizard. So at the moment, they are just open beta, distributed tracing, Anypoint Insights with the caveats around Cloud Hub and RTF, but telemetry exporter is actually GA. So very exciting. This was announced on stage at TDX. And yeah, it's a big area of investment for us. We're really excited to get these features out to you. So that's the distributed tracing of it all. Well, I guess the monitoring and the health monitoring aspect. Now the juicy good stuff at the end, as I promised. How does AI come into this story? Again, I'm going to flash up the forward-looking statement once again, just to say a lot of this, most of this isn't in the roadmap. This is more like a thought leadership and talking about the industry as a whole, rather than actually what's in the product. But we're investing a lot, so who's to say? So I'm going to frame this by frame how AI is going to be impacting the world of monitoring distributed tracing via the different problems that AI is going to help solve. The first one is the configuration issue. I already talked about this a little bit. So just to reiterate, it's hard to get your application network, or it's a barrier to entry to get your application network completely set up. To pass these traces they move across, it's hard enough for a network that looks like this. Imagine how hard it is for a 1600 microservice or microarchitecture application network. It becomes exponential almost challenge to get a network like this set up to handle traces. There is a solution, however, and that is distributed tracing for Cloud Hub 2.0, which I talked about on maybe 4 slides back. Available today, public beta. So if you host all your applications via Cloud Hub 2, this isn't an issue for you because MuleSoft's doing the hard work there. Every app that is deployed via Cloud Hub 2 is already configured to pass these traces. So but we understand, is it best practice to run every single app you have in Cloud Hub 2.0? Yes, of course, I have to say that. But we're realistic at MuleSoft. We understand that's not how all IT organizations operate. So you might have a network like this. So what do you do in a situation like that? Well, there's already kind of some solutions. There are no code setup agents offered, in fact, by the OpenTelemetry project, but they're sort of rudimentary. They're not perfect. But in the next 2 to 5 years, it's probably likely that there will be tools available that can go through these networks and automatically set them up to pass. So it's going to remove a huge barrier to entry for distributed tracing and make it a lot quicker the time to value. So that's kind of the first problem. Next is the sampling issue. So I didn't talk about this in my talk when I was going through distributed tracing, but as an industry practice, this is across the industry. This isn't just MuleSoft. Sampling is involved when you capture these traces. So you have your application network. You will take a random sample. Best practice is like between 10 and 15% at the moment. Of that random sample of 10 and 15% of your request traces, the only traces you're interested in to look at really are the ones where things are going wrong. So of that, you find your traces of interest, and that's actually what you look at when you're evaluating your health data within your application. And if you think about it, as I said, if you have all your requests, all your traces that are moving across your network, you don't care about the majority of them that are working, that work well. If it's processing perfectly, you don't want to analyze it. There's nothing to see there. What you really care about are only the ones where things are going wrong, those traces of interest. In a perfect world, these are the only ones you would capture and store. But if you think about it, to find those traces when your application network looks as complicated as the Monzo one, to take all those traces creates a huge amount of data. It's a huge data set, and it can be really hard. It's like finding a needle in a haystack looking for the wrong ones and the things where ones are going wrong. That's why we do sampling right now. But what's a technology, an AI technology that we're all becoming intimately familiar with, that's very good at passing through large data sets? Of course, I'm talking about LLMs. So it's not unforeseeable in the future that you could use a Copilot LLM and prompt it to poll your traces. So you can say something like, of all of my trace data that we have stored, I only want to see the ones that have above average latency. And of course, the power of LLMs is being able to build upon your previous requests and use natural language. So you can build on that and say, okay, what requests through errors or exceptions, for example, and then you can again build on that as well. And you can find the intersection of that set and say, oh, did any of those requests have empty or above average payloads? So this is a super powerful tool. Again, something not on the near term, but probably within the next 10 years, we'll have copilots there able to support developers in their troubleshooting when they're trying to fix these issues using these traces. So that's LLMs and the sampling issue. The next is the trace enrichment issue. So at the moment, I've talked about it just now. Like guys, they say the traces, they're quite a heavy data set. It's quite comprehensive. At least in terms of the number of requests. And because of that, the actual payload is a little bit smaller. It contains just things like latency exception, payload details, and that is limiting. It's a smaller data set, and that's just a natural, so kind of a necessary evil because you don't want to have to store so much data. It's a performance thing. But in the future, it's not inconceivable that traces will be able to capture a lot more, pretty much everything you could want, all the data you could want when trying to troubleshoot an issue with your application network. I've listed some of them on the slide here. So with those three problems and solutions in mind, I'd like you to close your eyes for a second. You don't have to close your eyes actually, but imagine with me in your mind's eye this world where you have your application network. It's already it's a one-click instrumentation that goes through and sets up your application network to pass traces. You then, of those traces, you have a super rich data source where it contains all these different information values, everything you could ever want when you're trying to troubleshoot an issue. And then if you have an issue, if it does occur, you have an LLM as your co-pilot when you're trying to deal with those 100 people breathing down your neck. And you can just use natural language to very quickly understand and resolve issues in your application network. So if you think about it, this is pretty much everything a developer ever needs to debug any kind of software issue. That's the paradigm shift we're talking about. And with that in mind, traces essentially have the potential to be the axis around which all modern, or future, I should say, troubleshooting for application networks and health monitoring is built. So with that in mind, with traces being the future, why not get started with MuleSoft right now? Something we're investing in. As I say, it's a really important investment for us. We fully believe in the technology, and we intend to be innovators in the space. So don't get started now. And that is the end of my presentation. I'm going to stop sharing and switch back.
Great. So there's two questions that came up during your presentation. One of them I knew the answer, but I'll just concern. The question is only in Cloud Hub 2.0 and then eventually RTF. So again, I did a presentation last Dreamforce where it was reasonably well stated. Cloud Hub 1.0, I don't want to use the word maintenance, but all the investment in new features are going to Cloud Hub 2.0. Is that a fair and accurate statement?
100%. I see someone there really trying to make me get off Cloud Hub 1. That's kind of my job in these talks, I would say. Is a big part of it is we want people to transition to Cloud Hub 2 for good reason.
Containerization is your future.
Indeed.
And then another question that came up, how is Trace ID different from Correlation ID? I'm not sure if you talked about those. Like a lot of developers will use Correlation ID, but that's an instance in an API, I think, and maybe they'll pass that through. Go ahead.
I actually don't have any of the context of that. I've not encountered this as a technical concept. So unfortunately, I can't answer this, but I can ask the product manager and find out.
That'd be great. So basically what it sounds like you're doing for all cloud deployments, you're basically putting an agent on top of your or somewhere in your container that allows you to collect a trace information that can feed into the UI, or ultimately you can export down a Datadog or something like that. Is that more or less
Exactly.
Perfect.
Yes, it goes at Anypoint Monitoring if you want to, but we understand, like, of course, we have our monitoring capabilities, we stand by them, but we know monitoring is its own entire market, and you want to use your Splunks, your Datadogs. So yeah, you can use telemetry exporter, open telemetry for that need.
Awesome. Last call. Does anybody have any questions for either Aston or myself? Going once, going twice. Sold. All right. Well, that is the end of our special Denver MuleSoft meetup today, focusing on TDX presentations that were just given last March. Aston's was bright and early in the morning on Wednesday, so people came back from the concert. He still had a pretty good audience, including me. I had enough of tea and enough of caffeine. I was wide awake.
Sure, the red eye slot. That's why I described it a lot, even during the talk. The red eye conference slot.
The red eye conference. So once again, we will post these slides up to the Denver MuleSoft Meetup group, same place that you registered for this, and we'll get the videos somewhere in the world.
YouTube.
Huh?
It'll be on
YouTube. Yeah, it'll be on YouTube, but the question is where on YouTube. That's
sure.
The part I don't know yet. But
MuleSoft
we'll figure it out.
Yeah. Cool.
Awesome. Well, thank you everybody for taking time out of your day to attend our TDX24 talk series. Aston, thank you again for making it, and I wish everybody a great rest of their day. And our next Denver MuleSoft meetup, I will be announcing that probably next few weeks. We'll probably do it in person again. We'll try a middle of the day thing, bring in some sub sandwiches or something. Probably again at the Salesforce office in downtown Denver. Once again, all right, thanks everybody, and thank you again, Aston.
Thank you very much. Take it easy.